So for this problem, problem 4.15 from the textbook, the unit operation here is distillation column. Okay, so first of all, what you have to do is from the question, try to figure out the block flow diagram. Okay, so because this is a distillation column, so usually distillation column you will have one input and two output, which is the top stream and bottom stream. So automatically in your mind, when we're talking about unit operation like distillation column, you will have one input and two output, one at the top, one at the stream. Either you call top, bottom, or distillate, something like that. So from the question have been given to you, the liquid mixture that going to be separate have 0.6 weight percent of ethanol, and then you have 0.05 of solid, and then the remaining is 0.35 of water, because the total here must be 1. And then the question mentioned a stream of product stream emerge at the top and the bottom column, so top and bottom. So at the top stream contains 0.9 of ethanol, and no dissolved solid, means no S here, and only the remaining is water, so you can put it here 0.1 is water. Then it didn't mention anything about the bottom, so means all will become unknowns, and all these three elements will be exist at the bottom stream. Because there is no information regarding volume or mass inlet or outlet, so we can assume a basis for inlet. So let's say we can take basis for inlet is 100 kg per second. Then the question mentioned that the mass flow rate have equal mass flow rate for the outlet, so we just have to label M because it has equal, so we just put M. If it has two different values, so you can label it as M1 or M2. And here, because we don't know what is the fraction, so we can label it as X1, X2, and for this solid, 1 minus X1 minus X2. Okay, don't create X3, which can add up more unknown here. Okay, now we finish with the BFD and the labeling the chart. Next we move to DOF, degree of freedom. Okay, so first we have to calculate how many unknowns we have here. 1, because this is the same level, mm, so 1, x1, x2, 1, 2, 3, so you have 3 unknown. Okay, and then how many component we have here for balance? We have ethanol, we have solid, we have water, so means we have 3 component balance. So we don't have other information, let's say specific gravity or any relationship have been given in the question, so that's all, means the DOF is 0. So we can solve this question by reflect to the degree of freedom, which is 0. So we can start with the overall balance first, it's much easier. So overall balance, as we learned before, overall is inlet equal to outlet. So here we have 100 kg per second equals to outlet, which is M plus M, okay, which contribute to 2M. So here you can solve M mass flow rate for outlet, which is 50 kg per second. So this is the answer for the mass flow rate. Now we finish with M. We have x1 and x2 to be solved. So to obtain x1, we can use ethanol balance. So ethanol balance, again, you are using inlet is equal to outlet. So we know the inlet for ethanol is 0.6 times by 100 kg per second and equal to outlet. Outlet at the top for ethanol is 0.9. Okay, and then we know the mass flow rate is 50. Okay, and then here we don't know x1 times with 50. So now we know x1 or mass fraction for the ethanol at the bottom is equal to 0.3 kg. Okay, ethanol per second. So we already had x1. Now we want to solve x2. So how we want to solve x2? We use the water balance. So water balance. So for water balance, again, we can use inlet equal to outlet. So inlet for water balance is 0.35 is the mass fraction times with 100 the mass flow rate for inlet, and then at the top product is 0.1 times with 50. Okay, plus we're going to determine x2 times 50, and then you will get x2 is equal to 0.6 kg of water per second. Okay, now for the solid mass fraction, it's easier. It's 1 minus x1 minus x2. Then you already have 0.3 and 0.6 plug in. So you will get the mass fraction for solid is 0.1 kg solid per second.